All right, scientific notation is really just a way to express a really large number in a smaller format or a really small number in a smaller format. When I mean smaller, I mean less digits to it, okay? So what this description says is a positive real number can be written in scientific notation in the form of c times 10 to some n power. The only specification is that c has to be in between 1 and 10, okay? So it's going to be a one-digit number, or one digit in front of the decimal at least. And n has to be an integer, which means a positive or negative whole number. And then I just gave you an example of what scientific notation looks like. It's 2.25 times 10 to the fourth. Okay. So what we're going to do is we're going to start with a number, and we're going to turn it into scientific form, and then we will go to scientific form and turn it into a number. Maybe. If my tablet would respond to me, would be helpful. Here we go. All right, so if you will take a minute and write that first number down, we're going to talk about how to write it in scientific notation. Most of you, if not all of you, have probably done this in science class before. It's just a lot of zeros, that's all. It's 3, 8, 5, 6 with 12 zeros to it. So essentially what we have to do is to turn a number into scientific notation is we are going to take the decimal from where it is currently. Where is it currently? Behind the last zero. Yeah. So our decimal, I'm going to go ahead and just put it in there so we can see it. So what we want to do is we want to take that decimal and we want to move it behind the first non-zero digit. When I mean first, it's how we read from left to right. So what is the first non-zero number? Well, from left to right? 3, right? So I want to move that decimal behind the 3 because we have to make the number between the 1 and 10. So here's what I'm going to do is I'm basically literally just going to count how many times I need to move the decimal because that's going to be what our n is in our scientific notation. So I'm going to count, and you don't ever start where you start. You don't count until you move one. So I'm going to go 1, maybe. See if this works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have to move it 15 times, right? Got to move it behind the 3. So what that does is that turns my number into 3.856 times 10. The exponent on the 10 is how many times we moved it. You just have to decide if it is a positive number or a negative number. Now, some people will try to remember left and right, but it's opposite depending on which way you go. So here's what I look. Is that number that we started with a big number or a small number? It's a big number. So that means my exponent is going to be positive. Okay, if my number is big, if I start big or I'm going big, my exponent is positive. And the exponent is just how many times did we move. So how many times did we move? 15. So it's just going to be a positive 15. That's just part of the, if you remember right here. Because multiplying or dividing by 10 is just moving the decimal. So that's why we use 10. Is everybody okay with that one? All right, let's try 2 then. I have 0.000000275. Is this a really big number or a really small number? Really small. So again, we're going to start where the decimal is, and we want to move it behind the first non-zero digit. What's the first non-zero digit? 2. So let's count. Beginning where we are, we're going to go 1, 2, maybe 3, 4, 5, 6 times. So it becomes 2.75 times 10 to the, this time because it's a small number, my exponent is going to be negative. Not bad, right? Has everybody got those two? I would like for you to try these. Write those in scientific notation for me, please. Again, today's stuff is not difficult. It does not take this long. The good news is you will have several of these types of questions on the test on Friday, so they should be relatively easy. Behind the decimal, there are 6, 7 including the front one. But after the decimal, there are 6 of them. All right, in number 3, where is my decimal currently? Behind the last 0. And I want to move it to behind what number? 4. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So it is going to be 4.52 times 10 to, is it a positive 9 or a negative 9? Positive. And number 4, where do I want to move the decimal behind what number? 4. 1, 2, 3, 4, 5, 6, 7 times. So it is going to be 4.3 times 10 to the negative 7 because it's a small number. Anybody have any questions? Okay. On going from a number to scientific notation. Okay, just count your decimals. If it's big, the exponent is positive. If it's small, the exponent is negative, however many times you move. Now we're going to go backwards. We ready? Are you okay? Is it hard to count up there on the TV? So it's 0, a decimal, and then 6 zeros, and then 4, 3. Okay. So in this, it's going to tell us to write each number as a decimal. Now, remember, whole numbers are also decimals, right? Because there are decimals behind it. We just don't always write them. So basically, we're taking this out of scientific notation. We're going to start with 2.869 times 10 to the 5th. I'm getting it out of scientific notation, writing it as it will either be a whole number or decimal, but technically whole numbers are decimals too. So I'm going to write my number just a little bit lower so I have room to make my movements. It's 2.869. How many times am I going to move my decimal? 5. And it's a positive 5, so I need to make my number bigger. Which way do we move it to make it bigger? To the right or to the left? To the right. So what I'm going to do is I'm going to count. 1, 2, 3, 4, 5. There is my new decimal. What do I put in those empty spots? Zeros. Okay. So if I wanted to write my number properly without all that mess in front of it, it's 286,900. So 286,900 is what it would look like. All right, same thing with number 6. We're going to start with the 1.03. This time I'm moving my decimals 3 places, but I'm going to move them to the left. 1, making it smaller. 1, 2, 3. And again, in those empty spots, I'm going to fill in zeros. So 0.00103 is my answer. You can put a 0 in front of the decimal or not. I don't care about that. So far, so good. Try those last 2. In number 7, I have 8.1 times 10 to the 4th. I am going to move my decimal. How many spots? 4. Which direction? To the right. 1, 2, 3, 4. That's 0, 0, 0, 0. So my number is 81,000. And then for number 8, I'm going to move this decimal. How many spots? 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Filling in those zeros. That's 1, 2, 3. Come on. 4, 5, 6, 7. So it's going to be a decimal, 7 zeros, and then 3, 7. And again, you can put a 0 in the front if you want to. That part doesn't matter, just as long as you have 7 zeros in between the decimal and the 3. Anybody have any questions? Okay, again, scientific notation is just a way to write big numbers a little bit more compact and small numbers a little bit more compact.